pass over to yourself, Mark.
Okay.
Yeah, so
well,
lovely. Sorry, Mark.
Okay.
Over to you.
Right, thank you, everybody. For those of you that don't know me, my name is Mark Ward. I'm a principal engineer in the Technical Authority Track team. I've been in and around gauging for quite a long time now. It's probably best part of 20 years off and on. So yeah, it's a very strange area of the business to be in sometimes. Yeah, so this is a little bit about where we currently are with gauging and where we're going with it. I'll touch on a couple of things. So one of the big things for us at the moment is we're just in the final throes of getting stakeholder approval for our new internal gauging standards, which changed the way we do things slightly. It gives us a bit more of a risk-based approach, which I'll cover. I cover a little bit of the work that we're doing alongside RSSB, so some of the things that we're working on, and also touch on something that you may not have heard of, which is called probabilistic gauging, and it's a new technique to try and really make the gauging analysis more representative of actual clearances. So first thing is, usually when I'm doing this in a room, I ask what people think when does structure gauging matter. So I'll run through the list. So when we're doing new vehicle introductions and cascades, so we need to know, is the vehicle going to be compatible with the infrastructure and vice versa? So it's important that we have a gauging analysis at that point. When we're doing new infrastructure design and build, so we need to make sure that our new infrastructure isn't going to hit the train for, clash with the first train which goes through. We need to make sure that 6 foot are wide enough to enable good passing clearances. So it's important then. Freight enhancements. So we seem to be getting ever bigger boxes that come in on these big ships. A nice big square boxes, which don't really work very well with our arched overbridges. So when we're doing freight enhancements, we need to know how much room we've got to safely run freight around. Infrastructure renewals. So if we're doing a track renewal, for example, we need to make sure that when we put the track back in, we're getting sufficient clearances to existing structures. Likewise, if we're putting a new, rebuilding an overbridge, we need to make sure that overbridge gives us clearance to all the vehicles which are currently operating and maybe operating in the future if we've got that level of visibility. It's like allowances for electrification. Infrastructure maintenance, we need to know if we're tamping the track and moving that around, we need to make sure that we're not affecting clearances in a negative way. Platform train interface management. So obviously platforms are a bit special. We need them to be close enough so people can get safely on enough trains, but not so close that we hit them. So we need to know where we are in terms of gauging and stepping distances at that point. Vehicle modifications. So if we're doing any additional bits of modifications to a vehicle, so the example I always use is we've been through quite a few fleet enhancements recently, putting Wi-Fi on. Those have all got antennas which sit on the roof of the vehicles. We need to make sure that we're not going to knock those off on the first overbridge that we come to, and it's still safe to operate. Freight and passenger diversions. So if we have, for example, something's gone wrong on the main line, can we still get that freight from A to B? What do we do with all the passenger vehicles which are sat there on the line waiting to move? Can we send them via alternative routes? Steam locomotive movements. So we got a big focus on getting passengers back onto the railway. Leisure travel seems to be a bit that's really being focused on. Part of that is running steam locomotives and other charter vehicles around. They're not fully permanently cleared in the section appendix to operate, so we need to know that we can safely gauge them and they'll fit the infrastructure. Out of gauge loads. I think I might have dropped out again then. So out of gauge loads, so things like big military movements of military equipment that sometimes comes outside of the existing vehicle gauge. Are we safe to move those? Things like wind turbines and pipes for the oil and gas industry, we also move them around quite a bit. So we need to assess that we are safe to move them. So there's just some of the examples of when gauging matters. Couple of examples here. So stepping distance, obviously that's a nice big wide gap there, which is quite dangerous for our customers. High output track renewals, are we safe to run adjacent line open in those cases? New infrastructure, that's a Warrior armored personnel carrier, got that right. You can see there that's got an offset on the turret, and what we have to do when we're moving those around the country is we make sure that that offset turret sits in the 6 foot away from any arched over bridges. So that's the sort of things we get involved with and why it's important. So talk about data requirements. So we need a good infrastructure model to assess how big the infrastructure is, where the rails are relative to the arched over bridges or tunnels and any other structures. We need a vehicle model. So how big is the vehicle going to be? Each train is fairly unique now in terms of the passenger vehicles. They all have got the footsteps in similar but different positions. We have long trains, so 20-meter vehicles, 23-meter vehicles, 26-meter vehicles. They all have different throws when you get to curvature. So we need to understand what that's doing. So high level overview of the infrastructure model. This is what we call a format for an SC0 file. So that is formatted from RIS 7773, which is the specification for it. So within that, we need to know what the survey method is. So the different survey methods have different tolerances. Bear with me 1 minute, apologies for this.
No issues. Yeah. Yes, Mark, you're back. Sound's off now, Mark. Can't you sound?
Sorry about that. I'm having some
No
real
problems
with connectivity today for some reason.
If you maybe want to turn your camera off as well, then sometimes that helps.
I'm tethered to my phone now, so hopefully that'll work.
Brilliant.
I live opposite one of the green boxes, and open drawers in there pulling cables out, and they shouldn't be. I'll turn my camera off. Hopefully that'll help with the bandwidth. Okay, so the line speed will affect how much the train's dynamic movements are.
Presentation's gone as well, mate. Sorry.
Hang on.
Here we go. No. Yep, that's it. Perfect.
Been one of those weeks. Right, so line speed will affect how much the dynamic input is in the train. Survey method affects the tolerances. The rail coordinates. So we have 0, 0, 0, 0, 0. Attribute 3, that is the left-hand rail. So gauging is all relative to a point in space, which is the left-hand rail is the datum point. You'll see that the right-hand rail has got about 14, 30, 62, and then a value. So that effectively is your track gauge plus your cant and the data. Then you have the structure coordinates. So all of these coordinates relate to a point in space relative to 0, 0. It just helps build up that picture. The current formats are SC0, which are the structure profiles, SCP, which are the platform profiles, and SCX, which are the 6-foot profiles. If you want more information about what it is and how it's built up, it's RIS 7773 INS. Okay, very high level of the vehicle models. So again, it's a set of coordinates, and what you need to know is the critical cross sections. So what's the extremity of the vehicle, and where they are relative to the center line of the vehicle. So when it comes to a corner or so curvature on the track, we need to know how much those will offset by in terms of their end throw and center throw. The bogey centers and the bogey wheelbase data, that's all in the data in the vehicle model. So the bogey centers again can affect how your throws operate on the train. Vehicle dynamic data, so how much does the train sway around and roll for cant deficiencies? How much does speed increases and decreases affect that? What the suspension characteristics are, so a full train will potentially sit lower than an empty train. So it's all of those sort of things that you need to model. What the maximum vehicle speed is. So there's no point assessing a vehicle at 125 mile an hour because that's your line speed if the vehicle itself can only do 70. What the vehicle tolerances are, so how well it was built. So we're getting quite good nowadays at building fairly consistent rolling stock. The old days, some of the Mark 1s and 2s, there was quite a big tolerance on each different body shelf. You measured 2 at the end of a production line, no 2 would be alike. So what the vehicle tolerances are. Again, there is a RIS for this. So the RIS 2773 gives you the current format. It's a fairly well understood vehicle model format. It includes all of the above, and it's worth reading it because it's quite an interesting read because you go, that's what's included. It helps you understand what builds up these vehicle models. Gauging group standards and RISs. So the first one is 7073. So that effectively is how we categorize and manage clearances. RIS 773, which is the infrastructure model data. We've got 2173, which gives you some vehicle requirements. So how you describe the vehicle, where you would put the footsteps when you're building a new vehicle, what compliance looks like for stepping distances, and RIS 2773 for the model itself. Then we have RIS 8273, which says when you're introducing new rolling stock or new infrastructure, you need to do a gauging compatibility assessment to make sure that 2 play nicely together. So a big chunk of the work that I do is working with RSSB around current standards, future standards, and research. So currently there's quite a bit of work going on around 7073. So one of the things that we have as an industry is a big issue for us is the requirement for an allowance for window box. So where we have the older rolling stock with the drop light windows where you have to pull the door down to open the door from the outside, you had to have an allowance for that, which was 450 millimeters between the infrastructure and the vehicle. So currently there are no mainline TOCs operating fleet with drop lights anymore. So yeah, we've got this requirement in the standard to allow for it. So if you think that is when we're doing new infrastructure, that's fine because generally the bridges tend to be further away, tunnels tend to be bigger, but trying to fit existing a new track into existing infrastructure becomes an issue for us. So we spent quite a lot of time on the northern projects getting a deviation together to state that we cannot comply with the requirements for window box, but here, however, this is what we're doing and what the controls are. So it's something which is out of date. So charter services should have controls in place for that. So the requirement is that they have somebody, staff on each door, making sure that no one's sticking their head out the window trying to see the steam engine at the front. We've all seen people doing that previously. The Jacobite in Scotland was actually stopped from operating for 2 weeks because they weren't complying with the requirements to have managed that risk. So the ORR do get involved. So put forward a request for help to do a bit of research that to inform future standard changes. There is a requirement for 250mm for staff where we've got opening windows. Now, a lot of the modern rolling stock no longer has opening windows for staff to put their head out of. However, a lot of it does. So things like tampers, the plant team got quite involved with, quite excited about some of the deviations we're putting forwards. You'll see at some stations still the staff are putting their head out the window when they're departing from platforms. So it's understanding what we need to do for those locations. There's a big conversation around electrification at the moment. So 7073 was written about 3 years ago now, and it contains a lot of requirements for electrification. However, JLRT 1210, which is the electrification standard, was recently updated with some new thinking that needs to be reflected in either 7073 or removed altogether from 7073. The other thing we're doing at the moment, we're working with the RSSB. We've submitted a request for help around probabilistic gauging. What we're trying to do is to get a RIS together for that, which delivers a consistent, recognised way for doing probabilistic gauging. So what we don't want is each different project setting their own parameters around probabilistic gauging, and it becomes a nightmare for us then to manage it in terms of infrastructure clearances. There's a bit of work around the updates to W10 and W12, so they're two probably the largest gauging standard gauges that we have. The aim is to enable the new bogey types that we've got. So we're pushing the industry down the road of having low track force bogies, which obviously that's fine. They put less force into the infrastructure. However, they tend to move around more and sway more. So what we're trying to do is to make sure that we include the new bogey types within the existing infrastructure space, yet still allow them to be compliant to W10 and W12. So there's quite a big piece of research that's going to be kicking off very soon around that. What does safe stepping distance look like? So compliance is very easy in terms of stepping distances. You're either in or you're out. However, a lot of our locations, we're just outside. Is that still safe? So we're trying to understand what the grey areas look like. Are we still safe at those locations, or is it, we need to put more focus into that? Okay, network rail standards then, we are changing them. So we have a new standard coming in called 3204, which replaces 3201 and 3203. So current standard 3201 is effectively what the TME needs to do to manage clearances. 3203 is what we need to do to collect the data, process the data, make it available to our stakeholders. So we've had a review of the existing standards. They were written in 2011, so they're long overdue for renewal. All based around what we call our bow tie risk management process for gauging. So we have a high level event, which is the loss of positive structure gauge clearance and or passing clearances. We had a moving rail vehicle into the mix, then you have an issue if you've got to that point. So what are we trying to do? We're trying to improve data collection. So making it easier for new surveying methods to come in. So there's a big push at the moment on point cloud, trying to get those into use. So measure the infrastructure once, use it for many different purposes. So getting your OLE, getting your gauging data, getting your digital twin, doing it all from point cloud. Data currency, so making sure that our data is up to date effectively. So there's a bit of a push on that. more of a risk-assessed approach to gauging management. So at the moment, we treat all foul locations as the same level of risk, whereas that's probably not correct. Some fouls are worse than others. So if you've got a straight track, for example, the track is less likely to move than it's where you've got high curvature. So the risk would be higher than curvature than it would with the stroke. So we're looking at wide and low platforms from PTI. So effectively, a high platform or a tight platform is actually quite good for a passenger because it's narrowing that step between the railway footstep and the platform edge. So we're looking at only the wide and low platforms in terms of understanding where we've got those and what it looks like. Okay, the publication date is December 23, which may or may not slip by a month. I've had a very long conversation today with a couple of stakeholders. Compliance date would be June 24. So we've got basically 6 months from publication to compliance of the standard and get a plan in place to enable compliance. So as part of the risk assessment, doing quite a bit of work. So I picked the Derby area because I live local to there, and the TME for Derby, they have 2,400 structures. When you go through all of the risk assessment and sort of filtering and sifting of the data, there's only 42 that they need to do a risk assessment on. So there's not huge amounts of work over and above what's currently being done. In fact, it's probably less than is currently being done, but we're focusing on the ones that matter. So that's the main driving the standard change. Okay, a bit about the network rail systems we use for gauging. So National Gauging Database, we moved to Railway Gauging Data System in August this year. So it's gone live last month, fairly stress-free. There's a couple of glitches along the way. We're working pretty hard to overcome them. But effectively, as an end user, if you're currently using ClearRoute, you will still be downloading your data from Balfours to use within ClearRoute. INM, so our infrastructure geography, where we are with it, where it sits, that is where we hold that. So that's our vehicle, our infrastructure model, what tracks go where. NESA, where we get our master for our line speed data from. We are not very good at aligning infrastructure engineering data with operational data. So there's a bit of a mismatch between those two, which we're trying to work and get around. Vehicle matrix. So being able to work out the clearances for any given track, we need to understand which vehicles and gauges are cleared where. When that comes in, where that comes into it is when we work out what our network clearances are. So we know for any given structure on the network what the clearances are to that structure. We know that because we know what the vehicle matrix is. So which vehicles are going to go past there, which freight gauges are cleared past there. So that all gets calculated up into Rift. An ellipse is where we manage our work. So anything that says you will go and do a manual check at this location gets put into ellipse. So they're the systems that we use to manage gauging. Move on to a little bit, talk about probabilistic gauging, which some of you may have heard of. So in this, I'll cover what it is, how it differs from absolute gauging methodology, which is the current one that we use, what it does for our efficiencies, what the limitations are. So it works, but it doesn't work everywhere. How we're introducing it and the challenges and risks around it. So first of all, our current process, I've talked about this a little bit. So we talked about all three of these things. So we've got an infrastructure data model. We've got a vehicle model, and we have the standard requirements that tell you how to calculate it. That all goes into a wonderful thing called gauging analysis software. So currently there are two flavors of that. There's ClearRoute, which is Omnicom Balfour BT, which probably most of you in this world will be familiar with. There's also a company called DGauge who have Rift. You put the models through all of this with the standard requirements that say these are the allowances you need to operate, you need to include in your analysis. Out of that, you get the absolute gauging output. So what are the clearances as per all the standard requirements against the vehicle and the infrastructure? So that doesn't change. So the existing absolute gauging methodology, we do the calculation, we get the outputs. So that it will say, bridge 10, you've got 50 millimeters, platform 2, you've got 2 millimeters, etc. So it gives you all the clearances. We take that and we allocate clearance categories to them as per 7073. So that ranges from normal, reduced, special, reduced. And at that point, when we have all of that, we then determine if intervention is required. So if we're introducing a new vehicle, for example, we would take the existing infrastructure model, we'd take the vehicle model, calculate the clearances, we'd work out then if anywhere has got fouls or clearances that we're quite concerned about and whether we need to do anything about it. So that could be tampering the track, it could be altering position of platform copers, could be any range of things. That's what we do currently. Probabilistic gauging methodology is slightly different. So we take the absolute gauging outputs, and the first question we ask is, have we got normal clearances? And if the answer to that is yes, effectively we're not interested in that, we just go down that route. If the answer to have we got normal clearances is no, we've got something tighter than that, then we move up to assessing it with the probabilistic methodology. And I'll talk about it in a bit more detail in a bit, but just giving you the overall process for you at the moment. So we do probabilistic gauging methodology on the places where we don't have normal clearances. And we get probabilistic derived clearances and clearance categories. We combine the two up. So it might be bridge 10. We use the probabilistic methodology to assess that one because it's less than normal. Bridge 11 might be normal clearances, so we'd use the absolute gauging output straight away without doing anything with them. Then we work out if we need to do any intervention. So that is the overall process at a very high level. So for the vehicle tolerances, this is the green is the absolute gauging approach, what we currently do. So we allow 2.12 SD allowance for dynamic movement. In probabilistic, we use a variable derived from multibody simulation. So what that means is everything will probably be at worst case, but not all at the same time is the approach that probabilistic takes. So for incremental loading, for example, so the dynamic movements that get put into it, currently we have to assess tear and crush, and we consider it as a one-off calculation. So we'll say that the vehicle, this is the maximum envelope that the vehicle can take up both in height and drop. In probabilistic, we'll do the calculation multiple times with various different conditions. Okay, so for loading, we apply a 10% incremental between tear and crush. So we'll assess 10%, 20%, 30%, 40%, etc., all the way up to 100% loaded. Vehicle condition, we have a deflated and inflated suspension considered equally. So for an absolute gauging analysis run, you assume that at some point the train is going to be deflated, so you allow for that in the calculation. So part of this is as high as it can be, this is as low as it can be, generally affects the height, so it'll be sat low in its suspension. For probabilistic, we apply a 1% deflated equation. We still think that is probably quite pessimistic because we're not getting 1 in 100 airbags going pop. The vehicle build tolerances are as supplied by the vehicle manufacturers. That's the same for both of these. And the vehicle speed is based on the maximum line speed, same for both. So you have to consider everything from low speed through to high speed in your gauging analysis. For the infrastructure parameters, they're all the same. The only one that we do play about slightly is what the tolerances are of the surveys. So we put a distribution on that. So when we calculate it, then I talked about it previously, for an absolute gauging analysis, you would do one clearance analysis. So this one structure, this one vehicle at this one location, these are the clearances. For probabilistic, you do multiple runs. So in this example, for run 1, you would say its survey tolerances is 10 mil. We've got 100% of our effective track position, so where the track can be under maintenance. We've got 10% loaded. We have an inflated suspension case and a 50% of the full dynamic movement range. For the second run at the same location, we'll change all of those up. Third run, etc. So we build up a whole load of different parameters around each of the individual bits that make up the clearances. At the end of that, it's usually about 10,000 calculations to get a representative value. You get distribution, so you get some weird stuff on the outsides that is where everything's at its maximum condition, and you get the weird clearances at the other end where everything's at its absolute best condition. Somewhere in the middle is the reality of this. So what it does, it takes around 95% distribution of the overall clearances and uses that as probabilistic probability of whether your clearances sit within this range. What it does for efficiency, well, first of all, it calculates more representative clearances. So when we calculate a foul in the current analysis methodology using absolute gauging, we calculate fouls at locations where the trains are going quite happily past them every day. Doesn't mean that there isn't an issue there, but what it does mean is that if all of the worst cases emerge and all at the same time, then you may have a problem. So it calculates a more representative clearance to what you like. See, that increases the calculated clearances under certain conditions. So it doesn't resolve every single location in the world. So there's certain variations of track geometry or line speed or vehicle where you're still going to get a problematic clearance, the same as whether you do it absolute or using probabilistic. It's got potential to reduce our maintenance monitoring. So if we're getting representative clearances, it enables us to inform the maintenance teams about what the real priorities are. So if we're getting a clearance that's shown as a real problem with probabilistic, potentially it's enabling them to prioritize where they need to start looking first. Reduction in infrastructure intervention for new vehicle introduction. So we're less likely to see problems at platforms for newly introduced vehicles, just because of the reduction in inflated and deflated conditions. It increases our infrastructure availability time. So we're not going out doing loads of alterations to infrastructure. We're not doing incremental measurement at locations. We're not doing additional maintenance tamping, because we know we've got that bit more representative clearances. It's not worst case that we're showing. It increases our understanding of actual gauging risk. So, not all foul clearances are the same. So it may be that some foul clearances that are calculated are actually less risky than our special reduced clearance, for example. Limitations to use around it. So the vehicle models, we can only use multibody simulation derived dynamic movements in the vehicle model. So that's software like Vampire and others that are available. So a lot of the older vehicle models are quite basic in their dynamic movement. This is pushing us more to getting better vehicle models. It can't be used for the freight W gauges. So the freight W gauges are, in most cases, an amalgamation of several different suspension types. Because of that, we can't do a proper dynamic assessment on them for probabilistic. Doesn't negate the group standard requirements, so we still need to put the platforms in the right position. We still need to build lower sector infrastructure gauge correctly. We still need to provide proper clearances for electrification. So it doesn't negate any of that. Doesn't resolve all locations. So we have got some genuinely tight locations. It's not a magic wand. They will still be a problem. how we're introducing it. So we did a trial a couple of years back now on the Glasgow-Mallaig route. We are currently undergoing a Network Rail safety review panel. It requires a RIS for the compatibility assessment purposes. So the Network Rail SRP will only enable us to use it to inform maintenance, just because it's gauging is an industry interface. If we don't have a RIS for it, we won't be able to use it to introduce new vehicles or infrastructure. So to that end, as mentioned earlier, we're working with the RSSB to have this RIS created. Risks and requirements for rollout. So the vehicle models, like I say, there are some limitations around which vehicle models can be used. We're looking at getting some limited vehicle models updated. The outputs of it currently only reflects what we do for absolute gauging, and we'll need to get it modified to adjust to show our probabilistic clearances as well. Okay, that is me. So at this point, I will throw it open to questions if anyone has any.
Yeah, we've got one question in the chat, but does anybody put their hands up first and come in and have a question there? Okay, then no questions at the moment then. So the first question is, surely new vehicles come in with new bogies and their characteristics, etc. unknown?
Yeah.
Old containers and wagons, perhaps not. But yeah, so it's a question around new vehicles. Do you know their characteristics as when they're introduced?
Yeah, so you can do it on individual wagons. If you've got all the vehicle dynamics which are applied via MBS, you can do it on the individual wagon and box combinations. What you can't do it on is the W gauges themselves, because the W gauge dynamics are an amalgamation of many different types of bogey. Effectively, what they show you is the worst.
Oh, sorry, Mark, we lost you on. Sorry, we lost you on worst then, or I did my end. I think probably the same.
Sorry.
No worries.
Yeah. So W12 is like a merger of many. So for W12, if you look in GERT 8073, which is the definition for the standard gauges, we have this thing called an established bogey types. For W12, there are just 3. So all of the low track force bogies which have been introduced recently, they're not covered by this. They sit outside of W12. So if you're introducing a new wagon, you find it very difficult to comply or demonstrate that you conform to W12. Part of the work that's undergoing at the moment and the research with RSSB is around getting the definitions of W12 improved without actually making the gauge size bigger. Hopefully I explained that okay.
Yep, sounded good to me. Yeah. So yeah, so I think so Vlad's just said that W12 is a merger of many.
Yeah,
I think that's what he said. Cool. We've got a hand up. Let me just see. Go to it. So we've got a hand up from Adam. Do you want to come off mute and ask your question, Adam?
Brilliant. Thank you. Hi there, Mark. Thanks for the presentation. You mentioned earlier about point clouds being used for probabilistic gauging. What's the maximum tolerances of the point clouds that can currently be used for this gauging method?
Okay, so point cloud can be used for gauging analysis. What you need to do, because obviously point cloud is very dense data, and what the process is for turning point cloud into gauging data, effectively we flatten it down to a 2D slice. what the resulting tolerances you get out of that depend on what the system is. So, you know, which initial point cloud surveying equipment you've got. So one of the requirements is to use point cloud surveying equipment is that it goes through Network Rail 3100 approval, which gives it this is what the absolute accuracy looks like in terms of where I am in the world and how it all sits into a 3D picture. From that, there's also an approval which will change from 3203 to 3204 in the future. That really is about how your relative accuracy is of that surveying system. So our worst surveying accuracy is 30 millimeters at the moment. Our best is 9 off the top of my head. So it will sit somewhere between there and there, but it's up to the manufacturer of that surveying equipment to demonstrate what their accuracies are. So yeah, we're part of the move to 3204 is about making it easier to introduce and approve new surveying equipment. So the use of point cloud is something that's a hot topic at the moment.
Good, thank you.
Lovely. And we've got a question from Paul. Paul Gray, go ahead.
Thanks, Ian. Yeah, thanks, Mark, for a really good presentation. Mark, just a crystal ball type question, please. How far off do you think we are on having like a digital twin from a gauging perspective, so we can sort of see the structures in a digital way that we can sort of see from a gauging perspective how trains might fit through with different configurations?
Thanks, Paul. That's a brilliant question. Where to start with it? So I'm of the mentality that gauging almost shouldn't be its own discipline. So what I mean by that is that, you know, we should build stuff in the right position and keep it there, and all the problems go away. You only at that point need to know what you're doing if you're introducing something new into the system. So you're introducing a new vehicle, for example. One of the things that's helping move this forward to having all of the data. So, you know, what we should be able to do is to put a pin through the data. So at location 10 miles and 3 yards on the infrastructure, we have an overbridge. That overbridge has got this amount of clearance. The geometry looks like this, lying and ballast condition is like. So putting all the data together in one place. Where we've moved slightly better than we were previously. Still not perfect because we've still got people walking around the track doing manual surveys, but the more we move into the world of proper, decent alignment to digital twins and having real intelligence within the data to be able to align it all properly. Crystal ball, we're probably about 10 to 15 years away from that. But if we can make incremental improvements along the way to get there, then that's brilliant.
Great, thanks, Mark.
Yeah, really good question. Thanks, Paul. Anybody else for any more? No, last chance. Let me just double check the chat. Okay. Yeah, as been said before, Mark, really great presentation, really detailed and comprehensive. So really great to see and to look where we're going and what's happening in the world of gauging. So could I just invite Paul Gray in to do the vote of thanks, please?
Yeah, thanks, Ian. Yeah, and thanks, Mark, for a really good presentation and battling through the our shared experiences with Teams, ups and downs, and the internet and all that sort of thing. A couple of points I noted in the discussion, and you and I work on gauging stuff from time to time. I really like the case studies that you talked about with that brought to life all the really intricate and challenging gauging discussions to do with warrior armored vehicles and the wind turbines. blades. You'd have thought railways are really good at that with you know, all the sort of wagon lengths we can have, and the match wagons and runner wagons and all those sorts of things. So that's really lends itself to railways. I think it's really good to see it sort of setting out the, you know, the what seemingly is a complex set of standards, but how they work together and how they sort of coordinate and deal with the different aspects of gauging is really good to sort of see it in a simplified way. I think probabilistic gauging is something that really will help us get the most from our existing assets and our moving trains around the country. So again, just really good to see how you sort of set that out, and with the path for us being able to exploit that capability in the near term. Generally the overall complexity of gauging is just, for me, in dabbling with it over the years, it's one of those subjects that we have to always sort of reflect the past and perhaps still go back to practices from 50 years plus ago, but we're always trying to bridge to the future as well. So it's really got such a span of different sort of computing times and manual surveys to very sort of advanced surveys, and all the time we have to sort of build in new and old technology constantly, which is both the fun, I guess, with the challenge of doing gauging. So yeah, thanks again for really bringing it to life and sharing your experience with the people on the call. So could I invite everyone to click their mics on, please, and give Mark the usual thanks really for the presentation. Thanks.
Yeah, thanks, Mark. Oh, just us. Okay. Almost worked. Yeah, so yeah, great. Thanks for that, Paul. And yeah, thanks again, Mark. So on that note, we'll bring the meeting to a close. And we'll see you in 4 weeks' time. Cheers, everybody. Speak soon.
Thank you. Bye.
Thanks. Bye.
Thanks all.